So have you ever wondered how a potato clock works? Me too. So today I'm going to be demonstrating what you need to make one, how to assemble it, and how it works. So right here in front of me, I have my potato clock. As you can tell, it is on, it is functioning. Some materials you'll need. You're going to need 2 potatoes. You're going to need a plate because when you cut the potatoes in half, it is going to create a little bit of a mess. You're going to need some thin wire because wire much thicker than that is probably not going to transmit the current very well, because this is going to be very low current, very low voltage coming out of this. You're going to need zinc and copper. Zinc you can find in galvanized metals or zinc plated metals. So nickel, a dime, newer ones are actually zinc plated. Those would work fine. A galvanized nail is most likely zinc plated. A copper nail would work, or a penny for your copper, or if your wire is copper, you could actually shove your wire down into the potato and it should work fine. You need some form of clock. This one came in a kit that I bought, but the clock could actually just be a watch, because if you look, there's actually a spot right there to put a battery in it. So when you take it apart, just make sure you know which side is the positive and which side is the negative when you're taking the battery out of your watch. And I think that is about all you're going to need for materials. Now when it comes to assembly, it's very simple. You cut your potatoes in half, you clean your potatoes before you cut them, because dirt, these do look very dirty, but I rinsed them off the best I could. The dirt can actually contaminate your zinc, and then it will no longer transfer electrons to your copper, so it will not work. So start off by cutting your potatoes, put them down on the plate, grab your zinc and copper, and make sure you have them alternating when you wire them. So you have this zinc going in to this copper, wrap the wire around tight, put them all in the potato after you have them wired, and make sure while they're in the potato they're alternating. So you have a copper and a zinc, copper, zinc, copper, zinc. That is connected to the watch. That's all assembly is, and it does work. So let's talk about how this works. So chemist Jan Key states that when zinc and copper are placed into the potato, the zinc oxidizes, causing it to send electrons to the copper, generating electricity. Teaching engineering says that, oh wait, not teaching engineering, real world physics states that the reaction happens spontaneously. It is self-driven. The electrons are forced to travel on an external path, and if the path connects to a device, it powers it. That external path is called a circuit. And Teach Engineering says that a circuit means that the electrical energy or charge is produced or stored somewhere and has a path for the flow to charge, or the charge to flow. So what they're saying is electrons go, this is negatively charged, this is positively charged. So the electrons go from the zinc to the copper. That generates a small amount of electricity, and it just continues across all the potatoes, generating enough voltage to actually power this clock. So in conclusion, we covered what you'll need to make a battery potato. We covered the assembly of the potato and how the potato clock works. I first found out about this my freshman year of high school. I had a physical science class where the teacher made a potato power clock, and I've been fascinated with it ever since. And that's about all I've got.